Well, hopefully he didn't actually try calling out for help and you didn't hear him and just
In your
got
haste
walked
to
in.
run away.
But it's not debating whether you're a dirtbag or
I'm really a dirtbag.
I've got to get to class. My students think I'm not coming and they'll go away.
All right, so we're on example 6 on page 335. So, says,
story problems or...
yeah, story problems.
Oh God, I thought we weren't doing story problems anymore.
Oh, we're doing story problems. During intermission at sporting events, it has become common for team mascots to use a powerful slingshot to launch tightly rolled t-shirts into the stands. The height, h of t, in feet of an airborne t-shirt t seconds after being launched can be approximated by h of t equals negative 15t squared plus 75t plus 10. Alright, so we got this function that describes the flight of a t-shirt being launched. Isn't that, so what does it say? It says, after peaking, a rolled up t-shirt is caught by a fan 70 feet above ground level. How long was the t-shirt in the air? So there's like the mascot out on the field, and we got bleachers, and somebody catches the t-shirt up. Isn't this how Ned Flanders' wife died? Okay, so there's this t-shirt getting launched, and it says after peaking, so it's going to come back down before they catch it. And how high did it say this person was off the ground? 70 feet above the ground. Alright, so this person is 70 feet. I'm going to be kind of a function nag. We don't have enough tools to totally function nag this, but let's function nag this. Input is t. What's that measuring? What does t usually stand for? Time. Alright, let me read this again. The height, h of t in feet, of an airborne t-shirt t seconds after being launched can be approximated by, so time in seconds. And this whole symbol output is
Height in feet.
height in feet. So if I input a 5, what does that mean?
5 seconds.
5 seconds. If I output a 5, what does that mean?
5 feet.
5 feet off the ground. Alright. If you ever take like a physics class with Chris,
If he's still alive.
you'll learn about...
Students in class.
Such a dirtbag. Alright, anyway, this kind of quadratic thing doesn't have slope or y-intercept like the mx plus b ones do, so it's not really fair to say what do these numbers represent. But in case you're wondering, this piece is representing gravity's acceleration downward, that's why it's negative. This piece is representing velocity, and this piece is representing an initial height. So I kind of don't like this. The mascot's 10 feet tall, but pretend we don't know that. We got this function. It's a quadratic function, just like we were doing last time. We all right with that? We were doing these equations, like we had stuff like x squared plus 6x plus 9 equals 0, and we were just solving to figure out what x was. Remember doing that last time? Vaguely. So how many answers did we get out of this?
2.
2 answers? Okay. So we're back to this function, and it says, after peaking, a rolled up t-shirt is caught by a fan 70 feet above ground level. How long was the t-shirt in the air? So we've got this 70 feet. Is that an input or an output?
Output.
Do we set it equal to 70?
Yep. So we're going to take this negative 15t squared plus 75t plus 10 and set it equal to 70. The question says, how long was it in the air? Doesn't that mean at what time did the person catch the t-shirt? And if we solve this, won't we end up with t equals an answer? So we'll have a time? Okay. So let's just solve this using skills we learned last time.
So put
Minus
the 70 on
70.
their side.
Alright, so we'll have negative 15t squared plus 75t.
Minus.
So I have a quick question.
Yeah.
So we'll get 2 answers for this, and one of the answers will probably be negative, which can't be applicable for positive time.
It's actually not going to be negative.
It's not going to be?
It's going to be, there's 2 places on here where it hits 70.
Okay.
and we want the second one.
Okay.
All right. Now what?
Close negative 15 out.
Negative 15 factors out of all three of those. Negative 15 factors out. We got t squared minus
Less.
5.
5.
T.
5t plus, we're taking the negative out, so that turns positive, negative, positive. 4 equals 0. These equations that equal 0 are pretty cool because we can just get rid of stuff we don't want. Divide by negative 15 on both sides. 0 divided by negative 15, still 0. So we got this pretty easy quadratic now, relatively easy. T squared minus 5t plus 4 equals 0.
-1, -4.
So negative 1 times negative 4 is positive 4. Negative 1 plus negative 4 is negative 5. Is this eligible for the shortcut? So we can just go straight to t minus 1 and t minus 4 equals 0. The next step in these equations was minus. Each of these chunks gets set equal to 0. So t minus 1 equals 0 and t minus 4 equals 0. Now what?
T equals 1 and
T equals 1 and T equals 4.
T equals 1, T equals 4. So we got two answers, and they are both legitimate answers because the math just tells us when the t-shirt's at 70 feet high, which happens twice, but the question says when does the person catch it, so which one makes sense for that?
4 seconds.
4 seconds, so they catch it after 4 seconds. This is not very realistic. I don't think a t-shirt would stay aloft for 4 seconds.
I don't think so either.
Isn't like football hang time for a kickoff like less than 4, 3 seconds? Alright, anyway, not very realistic, but there we go.
Well, you said the guy with the mascot's 10 feet tall, that's
Yeah. Alright, so 10-foot tall mascot, some major hang time for t-shirts. Any questions about the math for this though? Alright, with this function, setting it equal to something. Guys, if a story problem shows up on the test, it might be one kind of like this because I really like quadratic stuff. Like it a lot.
Or not, it doesn't have wonderful.
That's okay, no story problem would be good.
I thought you were going to say you really like 10 feet tall.
Mascots, they're kind of hard to ignore when they fall down.
It's true. I don't know, I'm still doing it. I'm a dirtbag. Alright, next problem.
You tell all of your other classes without him in it that you're a dirtbag, and somehow somebody will know him.
Probably. Alright, so we got this house.
We have a house.
Yeah, well, we know, but Lucinda and Felipe have a house. And they decide to plant a stake in order to build a deck at a right angle to their house. Lucinda and Felipe decide to plant a stake in the ground a precise distance from the back wall of their house. So there's their house. They plant a stake. They want this to be at a right angle. And they want to build a triangular deck because they're weird.
Yeah.
Alright, so they want to build this triangular deck. The stake will combine with two marks on the house to form a right triangle. From a course in geometry, Lucinda remembers that there are 3 consecutive integers that can work as sides of a right triangle. Find the measurements of that triangle. Alright, so
Really?
Lucinda's tape measure's broken.
Seriously. She needs to go back to Home Depot and get new.
Yeah, probably. Alright, so they want to build this right triangle deck, and they're like,
Home Depot.
you know, guys, back in the ancient days, they did stuff like this all the time, like Stonehenge that's all lined up with the solar system. She wants to make this cool deck that's got symbolic meaning. So she's going to make this
What
deck.
deck is triangle?
It says, it's a right triangle. Do you guys remember the Pythagorean theorem for right triangles?
A squared plus b squared equals c squared.
A squared plus b squared equals c squared. A and B are the legs of the triangle, meaning the ones that make the right angle. It doesn't matter which one's which. C is the hypotenuse. It always has to be the longest side, which is always the one that doesn't touch the right angle, right? Alright, so we got this relation for this. And the other rule that it said is, she remembers that there's 3 consecutive integers. What does that mean? What does consecutive integers mean?
1, 2, 3.
1, 2, 3, so they follow right after the other. Integers, whole numbers, so 3 consecutive integers. So if I call the first one x, what's the next one?
X plus 1.
X plus 1, what's the
X
next
plus
one?
2.
Plus 2.
So this is a math way of saying 3 consecutive integers and we don't know where they start. Which one of these is the biggest number?
X plus 2.
X plus 2.
So on this triangle, this piece has to be x plus 2. And the way I've drawn it, which one's the shortest side?
A.
A, so this one will be x, and B,
X plus 1.
x plus 1. This just happens to be how I've drawn it. It could be longer on that side and be like that and still be, then this piece would be x plus 1 and this piece would be x, but it doesn't really matter for the math. Okay, so we got A is the short side, B is the middle side, C is the longest side. And the way we've labeled them is x and x plus 1 and x plus 2 means they're consecutive integers. So now we can just put this into the Pythagorean theorem, and all we'll have is x's. So we can solve and figure out what x is. So we're going to have, we start with a squared plus b squared equals c squared, and then I make all those substitutions. We're going to have x squared plus x plus 1 squared equals
X plus 2 squared.
x plus 2 squared. Everyone alright with that step? Alright. Something that you probably knew when you first learned foiling, but you may have forgotten. When you've got something like this squared, that does not mean x squared plus 1 squared, right? You can't just square each piece. You actually have to
X plus 1, X plus 1.
x plus 1, x plus 1, and FOIL it. So this is going to be x plus 2 and x plus 2, and we have to FOIL that. Alright, so we still have this x squared. Let's FOIL this. First,
X squared.
outside, 1x, inside,
X.
another one of those, and last.
1.
Alright, so that stuff is all on the left side. On the right side, first,
X squared.
x squared,
2x.
2x,
2x.
2x,
4.
2 times 2 is 4. So if you had just squared these inappropriately, which some people will insist on doing, you'd get x squared plus 4, but you'd miss the outside and the inside terms. Don't do that. Make sure that when you square a binomial like that, that you actually FOIL it out. Alright, so instead of adding those together and then subtracting, should we just cancel an x squared off both sides?
Cancel a 2x too.
A 2x in both of those, like, because x plus x is 2x, so one of those goes away. So we got x squared plus 1 on this side, and on this side we got 2x plus 4. This weird symbol is an equal sign. Let's rearrange this so that it's ax squared plus bx plus c. What's that going to look like?
X squared
X
minus
squared
2x
minus 2x.
minus 3.
Subtract 4 from both sides and get minus 3 equals
0.
0. Alright, so that step, I guess if we show the math, we minus 2x off both sides, and we minus 4 off both sides. Ended up with that. Alright with that? Now it's just a factoring problem.
It's -3 and +1.
Eligible for the shortcut?
Yes.
So x minus 3, x plus 1 equals 0. So either x minus 3 equals 0 or x plus 1 equals 0.
X equals 3 or x equals
Alright, which one makes sense for this problem?
3.
This one that's negative, which is what you were talking about before, doesn't make sense. It's called an extraneous solution. Like, mathematically this makes sense, but geometrically it doesn't. What this is like if we had some sort of inside out interdimensional rectangle, its length side would be -1, which is kind of weird. So we got 3 for x. What does that mean back on this patio?
3, 4, 5.
This one's 3, this one's the next one bigger, which is 4, and the hypotenuse has got to be 5. You guys ever heard of a 3, 4, 5 triangle? You use them all the time in carpentry to make sure sheds are square and stuff. Alright, there we go. 3, 4, 5. Any questions? Alright, last story problem.
Like, you could also have it be like -1, 0, and 1.
Yeah, except for that would be an inside-out interdimensional triangle, so
Okay.
Doesn't-
They'd both be the same answer, right? Kinda.
I've never actually tried it. We should see if that works. -1 squared plus 0 equals 1 squared. Yeah, that would work out with the Pythagorean theorem. That's kind of goofy. It would work. Your patio would be like in another universe. You wouldn't be able to have very good barbecues on your
You can't have very
inside-out
good-
triangle patio.
Can't have very good barbecues on your triangle patio. either.
That's a small
I know. What do you do with this
That's a
pointy end
small
clear out here?
He's standing
patio.
Follow you, trip over it in the snow.
no one sees you.
I'm just worried about personal space on that.
That's where you
right?
put Uncle Rob's chair.
Put a planted tree right next to that part.
That's where Chris's chair is.
He's got his invisibility cloak on, it doesn't matter.
Yeah, but it's only post-it note size. All right. Never. This was a real conversation, I promise. All right. This problem. This problem. What we've got is I need to draw that a little bit bigger so I have something right. All right, we've got a baseball card.
That's not bigger.
Well, I drew the baseball card. Now I'm going to draw the plastic that's bigger. So we're encasing this in some sort of plastic to protect the baseball card. And we want the baseball card perfectly centered so it looks nice. Pretend that's perfectly centered and that it looks nice. All right. So what does it say? A valuable sports card is 4 centimeters wide and 5 centimeters long. So 4 centimeters by 5 centimeters. The card is to be sandwiched by 2 pieces of lucite, each of which is 5.5 times the area of the card. Determine the dimensions of the lucite that will ensure a uniform border around the card. Alright, so the only clues they gave us is that it's perfectly centered. We want a uniform border that's the same width all the way around, and that
5.5 times the area.
alright, so the area of the plastic stuff is 5.5 times the area of the card. What's the area of the card?
20.
Length times width, 20? 20 square centimeters. Therefore, the area of the plastic is what?
20 times
5.5.
5.5 times 20? What does that come out to be?
110.
110? Okay. So, what we need to do is we need to do a length times width thing for that. I want you to envision that I scoot this card all the way down to the bottom. How wide is this piece right here?
4.
This and this are the exact same size, right? Because it's perfectly centered. But we don't know what they are. What do we call it when we don't know it in math?
X.
Alright, so this piece is x, and since it's uniform, this piece is also x. So what is the entire length of this side then?
4 times 2.
4 plus 2x.
4 plus 2x? Can we write 2x plus 4 so it looks more like the other math that we do? 4 plus 2x will work out exactly the same. We agree with that? There's 2 x's plus the 4 that we know. So now envision that we scoot the card all the way over to the side. How big is this piece?
5.
And this is still uniform.
Be 2x plus 5.
So these are both x's, so this whole length is 2x plus 5. Good? Which means that if we're trying to find the area of the plastic is going to equal length times width.
Equals 110.
which equals 110. Alright with this? Okay. So, let's just solve this. Let's FOIL this and work our way through it. First,
4x squared.
4x squared. Outside,
10x.
plus 10x. Inside, plus 8x. Last.
20.
So I'm going to have 4x squared plus 10x plus 8x makes 18x. If I minus 110 off both sides, what do I have?
Minus 90.
Minus 90.
Minus 90 equals 0. Too bad that 4 doesn't factor out. Does anything else factor out?
2.
2? So if I factor out a 2, I'm going to have 2x squared plus 18x, no,
9x.
plus 9x.
Minus 45.
Minus 45 equals 0. So I can just divide the 2 off both sides and it disappears. 0 divided by 2 is still 0. So, sorry, let me take this all the way over here. What are we down to? We're down to
2x squared plus 9x minus 45 equals 0.
alright, so we gotta factor this. Too bad it's an AC method and not shortcut eligible. So we need factors of
Negative 90.
negative 90 that add up to 9. So it's not gonna be 1 and 90 or 2 and 45, 3 and 30. Does it divide by 4?
That would have been a lot easier initially. Because it was negative 90 over here. We factored out of. We
No,
tried-
that's
That one better than
22.5.
Well, we still would have had to times it by 4. So it doesn't divide by 4, does it divide by 5?
Yeah.
6
6? 6 and 15? Is that going to be the one that makes it work? Alright, 6 and 15. Which one's positive, which one's negative?
15 is
15
positive,
is
6 is
positive.
negative.
6 is negative. 15 times negative 6 is negative 90. 15 plus negative 6 is positive 9. So don't get impatient and just do x minus 6 and x plus 15. Not shortcut eligible because of this 2. So we need to do the grouping. 2x squared
Minus 6.
minus 6x plus 15x minus 45 equals 0. Group.
Take out a 2x
2x leaves us with,
minus 3.
so hopefully that's what we get in this next one.
15.
15.
Take out a 15.
X minus 3.
X minus 3. So we've got x minus 3 times
2x plus 15.
equals 0. So either x minus 3 equals 0 or 2x plus 15 equals 0. Which one of these is going to give me a positive answer?
X minus 3.
Yeah. So we're going to end up with x equals 3 as our answer. This one is going to give us x equals negative 15 halves, which is back to, it makes sense mathematically, but geometrically, we don't want like an inside out plastic that's in another universe. So x equals 3 is going to be our answer. Not our final answer, because the question says what's the dimensions of the card. Or not the card, the plastic. So if each x is 3, how wide is it?
10.
3 plus 3 plus 4 is 10. And how tall is it? 3 plus 3 plus 5? 11? Double check real quick. What's 11 times 10?
110.
25.
Not 225. 110. Good? Alright. There are your story problems.
Oh my gosh.